Hi guys, I'm creating some videos. I don't know if it will help you, uh, but I hope it helps you for your final exam. So that's the reason I'm creating. I thought of creating a few videos. If you find it helpful, you can watch these and try to learn from this. Or there are other YouTube channels which you already know, which you can watch. So in this video, what I want to tell you is this. I'll discuss about Turing machine. So, whenever you are asked to write a definition of something, like whether it is a Turing machine, a DFA, NFA, or a PDA, so whenever the question is to define or to describe what a Turing machine is, or a PDA or a DFA, you have to write this. This is the most important thing that you have to write. Like instead of writing all stories, you have to mention that tuple. Like GFS is a 5 tuples. So Turing machine is a 7 tuples. You have to write this, and then you have to describe what each element of this tuple means. Like for Turing machine, Q is a finite set of states, which I hope you already know what a state is and set of states is. Like sigma is input alphabet. Then, so these two are exactly the same as what you have in a DFA or an NFA. This is the new thing that you'll have in Turing machines, because Turing machine has something called a tape, and the tape can include both the uh, symbols from the input alphabet and also like blanks. So what you see on the right hand side is here is a the input tape of a or the yeah input tape of a Turing machine, and the blank symbol is shown as D. So that's the additional thing that we have in Turing machine. Then you have transition function, which you also have in a DFA or a PDA. So for all those things, also you have this transition function. So, like similarly, when you're asked to write, describe transition function of something, this is what you have to write. Like instead of writing stories about it, you have to clearly mention what the transition function is for that particular machine. So here, Turing machine has this transition function. So what this means is like Q cross the tape alphabet, right? So that means like if you know cross product, the result of a cross product is always an ordered pair, right? So here, when you say Q cross tape alphabet, it's an ordered pair of the form Q comma any of the symbols of the input tape. Like it can be A or B or whatever is there in the input alphabet, and it can also be like blank or other symbols which are allowed for a particular Turing machine. So that's what this Q cross. Uh, the symbol is called gamma, I think. So okay, so function, as you know, is like maps uh, from left to right. So here Q is the set of states, and gamma is the tape alphabet. So the cross product will be an ordered pair. So that will be the uh, that's what you have on the left hand side, and then it maps to the output. So this is again a cross product of three things, which means like Q cross, gamma cross, this set. So this means left, L means left, and R means right. So that will be a ordered pair of three elements. So one will be like the state to which uh, the transition happens. This will be the tape alphabet. So if you are leaving A as it is, then you'll have A, or if you are replacing A with a cross symbol, then you'll have a cross. And then comma, the last element will be whether you are, after reading the symbol, whether you are moving right or left on the input text. So let's say it's L. So yeah, that's how you have to describe a transition function. Now Q0 we know is a start state from, that's the same as all the other machines. There's an accept state which is Q accept, and there's a reject state which is also called the halting state. That means the machine has uh, entered halting state. So that's how you have to define something. When you have to define, that's how you have to do it. And then what you have, what you see here is like a description. This is the story that I'm talking about. So when you, this also you can write, but then this is what you're required to write. Okay, so this is like describing what the Turing machine has. It has an infinite tape or memory, which is shown in this figure here. So infinite means like it extends to both sides. So there is no limit on, like there is no leftmost or rightmost. So there can be symbols anywhere on this page. That's what it means. And then a read or write head, which reads one symbol at a time, right? So this is the read or write head, which reads the symbol, and then it can also write the symbol to the tape, and then that cursor can move left or right, right? So, and then the other thing that the Turing machine has is a finite control, which is like a set of states. So when you read a symbol, write to the tape and move left or right, you also can change states. So that's what a finite control is. So this is how you have to describe a Turing machine if you want to answer the question properly. So in the next video, we'll discuss how to design a Turing machine given a language. Okay, so see you in the next video.